So today we're going to learn how do we problem solve in chemistry. So we'll either learn or refresh a technique called dimensional analysis. So to start off, I just have this little meme for you. So read this meme. Tell me if you can identify with this. How many of you can relate to this? Can some of you relate to this with word problems? Okay. Okay. I like this little meme. Some of you can't relate to this at all, and then others of you feel like this is the story of your life. So today we'll go through some problem-solving tips of how not to feel like this, and then we'll work on like some techniques to help you solve some problems better. So to start off, here's just 5 steps to solving problems. Okay, so these are 5 things you should do that would help you solve like word problems or our chemistry-themed problems easier. Okay, so the first thing we need to do is we have to identify what's known or given in that word problem. Okay. Then you need to identify the unknown. So you have to be able to figure out, well, what am I actually trying to solve for? Okay. Third, you need to plan a solution. I call this the game plan. So you got to make a game plan. If people are struggling to solve a problem, it's usually because they skip this step. Okay. Before you actually do anything with numbers, you need to think through, how are you going to actually solve this problem? Then once you have your plan, you'll actually do your calculation. And then at the end, it's just time to finish up. So we're going to check our units. We're going to check, like, does that answer actually make sense? And then finally, we'll round to the correct number of sig figs. Okay, so when we solve problems in chem, we're going to use this technique called dimensional analysis. You don't need to write anything from this screen. Okay, it's just the method that we'll use. The word dimensional analysis, it just comes from the process. So you're going to use units or dimensions that are part of our measurements, and we're going to solve or analyze problems. So before we can actually do dimensional analysis, I just want to talk quick vocab. So we use something called a conversion factor. And you do need to know what a conversion factor is. It's just a ratio of equivalent measurements. And here's some examples of conversion factors. So one example could be $1 is equal to 4 quarters. Okay. So notice it's 2 different units, right? This one is in the unit of dollars, and this one's in the unit of quarters. However, are these 2 measurements equal? Is $1 really equal to 4 quarters? Okay, so they have to be equal measurements. And so we can use these conversion factors to convert units. So we could get from quarters to dollars or dollars to quarters. Another example is 100 pennies equal 10 dimes. Okay. Do 100 pennies actually equal 10 dimes? Yeah. Okay, they both have the same value. We can also write conversion factors like a fraction. Okay, so here I just changed it. It's now looking like a fraction. 1,000 millimeters are equal to 1 meter. Okay. So we can use this to convert between like meters and millimeters. You can do the same thing with grams. So here's 1,000 grams is equal to 1 kilogram. So there are tons and tons of conversion factors out there. You just have to make sure that whatever numbers you're using, they do have to actually equal each other. Okay. And then if you're ever not sure like which number goes with which unit, kind of a little hint here is, whatever the larger number is, it'll always go with the smaller unit. Okay, so let's think about like the penny one, right? So pennies is the smaller unit, and it gets the larger number, right? There's 100 pennies. And then dimes is the larger unit, so you get the smaller number. Okay, so kind of if you're not sure like what your conversion factor would be, this is like a good rule of thumb to follow. Let me show you how we write conversion factors. When we write conversion factors, we put them in fraction form, okay? So we put them in like the numerator and denominator. So maybe just give yourself one example. So here's my little fraction, okay? So my conversion factor is 1 inch is 2.54 centimeters, but the way we're going to write it is like a fraction. Okay. So you could write it as 1 inch in the numerator and then 2.54 centimeters in the denominator. And you can also switch it. You can put 2.54 centimeters in the numerator and 1 inch in the denominator. Okay. When we do practice problems, I'll teach you how you know which number goes where, okay? But when we write them, you're going to put it in fraction form. And the only key thing to think about is if it's in the numerator and denominator, these still have to be equal to each other, okay? So 1 inch is equal to 2.54 centimeters. So now we're going to go through a lot of practice problems together. Now the goal of today is not to just get the answer. The goal is to practice dimensional analysis. Okay, so I know some of you can read this word problem, how many minutes are in 2.5 hours, and I know some of you can like come up with the answer like this. That's not what we're going for today. Okay, our goal for the day is to understand how to do dimensional analysis. So if you're not working a problem out on paper with me, now is the time. So get out your paper. We're going to solve these problems together. And as we solve these problems, I'm just going to follow on those 5 problem solving strategies. Okay? So the first thing we have to do is identify what's given in the problem. So what number is given to you in this problem? Okay, 2.5, always put a unit with it. So what's our unit? Okay, so you've been given 2.5 hours. Next, we have to figure out the unknown. So what are you solving for? Okay, I just like to draw an arrow because I know I have to convert it to minutes. So the way I do it, I just put a question mark. I'm solving for how many minutes is that? Okay, so this is my known, my given value. This is my unknown. And then my next step is to make that game plan. So how am I going to get from hours to minutes? This is going to be a conversion factor. Okay, so how many minutes are in an hour? Okay, so I know I'm going to have to use this conversion factor that 1 hour is the same as 60 minutes. Okay, so now that we've kind of thought this through, I know how I'm going to get from hours to minutes. Then I'm going to do the dimensional analysis. Okay. The way I do it, I call these boxes. Some people might call them train tracks. Okay. So I end up with boxes. I'll show you another technique at the bottom when we're done. Your very first box, I consider this one, and you're always going to start with the number given. Okay, so in this word problem, you're given 2.5 hours. In your box, make sure you get the number and the unit. Then you have this bottom box. You may either leave it empty, or if you don't like empty boxes, you can put a 1 in the bottom. By adding a 1 here, did I change anything about the 2.5 hours? Okay. Personally, I put a 1 there. I don't like an empty box, so I put a 1 there. But you can have a 1 or you can leave it empty. All right, then in our next set of boxes, we're going to use this conversion factor. Okay, so for every 1 hour, there's 60 minutes. Now to figure out which number goes where, you have to cancel units. Okay, so I need my hours to cancel. So if hours are in the top box up here, hours has to go in the bottom box down here. Okay, so then 1 hour has to go in the bottom box. And then that means 60 minutes has to go in that top box. Okay. So then hours cancel. And what unit is left over? Okay, minutes. What unit do I want my final answer in? Minutes. Okay, so that's how I know I'm done. I have my unit that I want my answer to be in. Okay. So then I'm done. I'm going to put my equal sign. I would recommend the best way to calculate is just to take the top row and multiply the top row. So what's 2.5 times 60? Say that louder. Okay, 150. Now, if we had numbers besides 1 in the bottom row, we would also multiply across the bottom row. So I'm just going to show you this time. What's 1 times 1? Okay, so it's not always going to be 1 on the bottom. And then finally, you would just divide. 150 divided by 1, and what does that equal? Perfect. Okay, so this one is easy. It's not always going to be 1s in the bottom. Okay, last step is we're just going to kind of finish up. So does 150 minutes make sense, first of all? We know 2 hours is 120 minutes, so it's greater than that. So logically, does our number make sense? Okay. Then we're going to count sig figs. How many sig figs are in 2.5 hours? Okay, 2. 1 hour is equal to 60 minutes. That is one of our definitions. So this one's exempt from counting sig figs. We would say it has infinite. So we are not going to worry about it. So how many sig figs are going to be in the answer? Okay, and how many are in our number? 2. And then finally, you need a unit. What's your unit? Okay, minutes. Okay, so when I do dimensional analysis, I call this the box method. I just draw boxes. Some people call these like train tracks because if you get longer, they look like train tracks. Some of you might have learned it. Let me just show you like another format. You might have learned it like X in a line. Okay, if you learned it in like that format too, it's totally fine. Okay, so you pick whichever one works for you. All right, so now we're gonna figure out how many seconds are in 2 days. So we're gonna start with that first like problem solving strategy. What's the number given? Okay, so you're given 2 days. And what are you trying to solve for? Seconds. Bless you. Okay, so again, I just like the question mark, like how many seconds are we solving for? Then before we even worry about the dimensional analysis, you gotta make that game plan, okay? I know I'm gonna start with days. Do we know how many seconds are in a day? Okay, do we know how many minutes are in a day? How about hours? Do we know how many hours are in a day? Okay, so let's convert to a unit we do know. So we can go from days to hours. Okay. We have to get to seconds. Do we know how many seconds are in an hour? Okay, how about minutes though? Okay, so can we go from hours to minutes? Okay, and then can we go minutes to seconds? Okay, in your notes, like highlight, star, underline this step. Okay, this is super important, especially as our problems get more complicated. Okay, if you're not quite sure how you're going to convert units, is it going to magically come to you when you do your dimensional analysis? Okay, probably not. So this step is super important. Don't skip this step. Okay, now that we have a plan, then we can do the dimensional analysis. You're always going to start with the number given. Okay, so you're given 2 days. I put a 1 in that bottom box just because I don't like empty boxes. Could you leave it empty if you want to? Okay, it's up to you. All right, then I'm just going to follow the plan. I have to get from days to hours. So how many hours are in a day? Okay, 24 hours in a day. If days are up here, that means the unit day has to go down here to cancel. So then 1 day has to go in the bottom. And how many hours are in a day? Okay, so then 24 hours has to go in that top box. Okay. So then our unit of days cancels. Now we're in hours and we have to get to minutes. How many minutes are in an hour? Okay, 60. What unit has to go in the bottom? Okay, why does hours have to go in the bottom? Okay, it's got to cancel. So then for every 1 hour, there's 60 minutes. Okay, hours cancel. And then now we have to get from minutes to seconds. How many seconds are in a minute? Okay, 60. What unit has to go on the bottom? Okay, 1 minute has to go on the bottom, and then 60 seconds has to go on top. Okay. Minutes cancel, and then what unit isn't canceled out? Okay, seconds. And what unit do you want your final answer in? Okay, this is how you know you're done. You can add as many boxes as you need to for unit conversions. So you know you're finally finished when your only unit not canceled is the unit you need your answer in. Okay, so the next is time to calculate. There are lots of ways you can calculate this out, but I recommend you multiply that entire top row together. Okay, so 2 times 24 times 60 times 60. If someone has an answer, just like read me your numbers. 172? 800. Okay. Do y'all agree with that?
Yes.
Okay. If you had numbers in the bottom row, you would have to multiply that whole bottom row. Okay. And then you would divide. Since we have ones, this is just going to be our final answer. Okay. Last step is to just think through logically. If 2 days, does it make sense that there are a lot of seconds in 2 days? Okay, so logically that number seems to be about ballpark. Then we do sig figs. This one is going to be goofy for sig figs. 2 days could be counted as an exact number, like are we going for 2 exact days? Or you could count this as one sig fig, like just like a rough 2 days. So let's decide as a group right now, do you want to consider this exactly 2 days or just like a ballpark 2 days? Okay, ballpark. So it all depends on context. We're going to say it's just like roughly 2 days. Okay, so how many seconds are like in roughly 2 days? So then this counts as one sig fig. Okay, so then this would just be one sig fig. So how many sig figs in your final answer? Okay, you would have to round that. What would you round that number up to? Okay, so you would have to look at the 7. You would round it all the way to 200,000. Okay, so that means 2 days is roughly 200,000 seconds. Okay. Now, if we change the context and we wanted to know exactly how many seconds are in 2 days, then all of these are considered like exact numbers, and there are exactly 172,800 seconds. Okay. When we take like a test, I won't give you something that tricky. Okay. A lot of these. So next, how many cups are in 120 teaspoons? Okay. All right, so first thing we do is pick a new color. Write down what do we know. So what number is given to you?
120 teaspoons.
Okay, so I'm going to write down 120 teaspoons. What are we trying to find out?
How many cups?
Okay. Okay, so we want to get from teaspoons to cups. Next, we have to make that game plan, or we have to kind of figure out how are we getting from cups to teaspoons. Do any of us know off the top of our head how many teaspoons are in a cup? No, but what did I give you?
48 teaspoons in a cup.
Okay, so we're going to use the conversion factor I gave you. If it's a goofy one, usually I'll give you that conversion factor. If you're just like at home doing your homework, where could you find this?
Google.
Good, you could always just Google them. Okay, so I know I can just go straight from teaspoons to cups. So now that I know how I'm going to do the problem, I can actually start drawing the boxes. What number is going to go in that first box?
We could just do this mathematically.
Okay, so you start with the number given. Okay, 120 teaspoons. And then what unit has to go in the bottom?
Cups.
Nope, because what unit has to cancel?
Teaspoons.
Teaspoons. If teaspoons is up here, teaspoons has to go in the bottom. Okay. So 48 teaspoons has to go in the bottom, and then 1 cup goes in that top box. So teaspoons cancel. Okay. I'm left in the unit cup, and what unit do you want your final answer in? Cup. Okay, to solve it, we're going to multiply the top row. So what's 120 times 1? Okay, then we'll multiply across the bottom row. What's 1 times 48?
48.
Okay, and then we'll just divide those two numbers. So what's 120 divided by 48? 2.5. Okay, then we'll just finish up. 2.5, does that seem like a reasonable number? Especially if like you cook or you bake. 48 teaspoons is a lot, but like, you know, if you think like if you measure out, like I measure vanilla, kind of seems like about 2.5 cups worth. Then sig figs. How many sig figs are in 120?
2.
How about 48?
2.
So how many should your answer have?
2.
2.
And it has 2.
Good. So are we good there? Okay. Finally, you just need a unit.
Cups.
Perfect. So for this one, you have instead of $7.25, I'm going to keep it as 1 unit. So you have $7.25 in your pocket. How many quarters is that?
1.
So what number is given to you?
How many quarters? 7.25.
Okay, $7.25. And then what unit are you trying to convert that to?
Quarters.
Okay, so we want to know how many quarters. Okay. What's the conversion factor or relationship between dollars and quarters?
4 quarters equals $1.
Okay, for every $1, there's 4 quarters. So then I want you to try this on your own. Again, we're not as worried as can you get the correct answer, but I want to see, can you set up the boxes? Can you do the dimensional analysis? So let's check. What number did you start with?
7.25.
Okay, so we started with $7.25. And then what unit had to go down here? Dollars. So $1. And then what goes in the top?
4 quarters.
Good. 4 quarters. Okay. Dollars canceled, you're left in quarters. So if you multiply 7.25 times 4, what did you get? Okay, 29. All right, and if we think about that, does that number make sense? Okay, seems reasonable. Sig figs on this one don't really apply. 725, we're going to say is exact, right? Like, you have 725, that's an exact number. So we don't worry about sig figs. And then $1 is equal to 4 quarters is a definition, so we don't have to worry about sig figs. And that makes sense because if you have 725, you have exactly 29 quarters. There's no rounding. Okay, so 29, and then what am I missing? Units, so make sure you have a unit. Okay, again, I want you to try this one on your own, but I am going to help you. You're going from meters to centimeters. How many centimeters are in a meter? Okay, I'm going to give you 100 centimeters is equal to 1 meter. And then I want you to try to convert this problem. So a rattlesnake is 2.44 meters long. How many centimeters is that? Again, we're not just interested in the answer. I'm interested in the dimensional analysis. What number did you start with? 2.44. Okay, meters. And then what number had to go on the bottom? Okay, 1 meter. Why does 1 meter have to go on the bottom? Okay, units have to cancel, and then what number goes on top? Okay, 100 centimeters. Okay. And so if you multiply 2.44 times 100, what do you get? 244, and what's your unit? Good. Okay, 244. This time, do you see how we just did a metric to metric conversion? We went from meters to centimeters. You with me there? Yeah. Metric to metric. When you're going metric to metric, these are like exact conversions, so no counting sig figs. Okay. So if you started with 3, your answer has to be in 3. Okay, this one, how many seconds are in 1.4 days? We'll write your answer in scientific notation. All right, so what number is given to you?
1.4 days.
Okay, so 1.4 days. What are we trying to solve?
How many seconds in a day?
Okay, so we're trying to convert that to seconds. Okay, so there's my knowns and unknowns. Next, we've got to make that plan. Do we know how many seconds are in a day?
No.
Okay, so what unit can we convert to in between?
Hours.
Okay, so we can go from days to hours. Then what unit can we convert to?
Minutes.
Okay, then we can get to minutes. Then what?
Seconds.
Okay, seconds. So don't forget that plan. All right, what number do I start with?
1.4 days.
Okay, 1.4 days. Everyone check your paper. Are you actually putting units on your paper? If you're just putting numbers, you're getting a little lazy. Make sure you have units. I promise you need units. It will help, okay? Especially when preventing mistakes. So 1.4 days. Next, we're going to hours. How many hours are in a day?
24.
Okay, where are you going to put the 24? The top or the bottom?
Top.
Okay, why on the top?
Because you have to have the days on the bottom.
Okay, because it's 24 hours. Day has to go on the bottom. Why is that?
Because they have to cancel each other.
Good. Okay, they have to cancel. The name of the game is how do you cancel units. So then we get to hours and we have to get to minutes. How many minutes are in an hour?
60.
Okay, 60. Where does 60 go?
Top. Hours on bottom.
Okay, 60 minutes has to go on top because the 1 hour has to go on the bottom. All right, and so that leaves us at minutes, and then we have to get to seconds. How many seconds are in a minute?
60.
Okay, what unit has to go in the bottom here?
Minutes.
Okay, So I'm going to write for every 1 minute, there's 60 seconds. Okay. So then minutes cancel. My only unit that doesn't cancel is seconds. And does that match the unit you want your final answer to be in? Okay, that's how you check. That's how you know you're finished. Okay, go ahead and multiply that entire top row. Someone have an answer. Just say your numbers.
120960.
120960. Do you agree? Okay.
I just yeah.
All right. We are going to round. How many sig figs are in 1.4 days? Okay, so 2. These are all definitions, so we don't count them for sig figs. So how many sig figs in our answer? Okay. That 0, is it going to cause us to round up or down?
Down.
Okay, down to 120,000. And then how does this question, how does it want your answer?
Scientific notation.
Okay. So this turns into 1.2 times 10 to what power?
Fifth or sixth? Fifth.
Fifth. And what's your unit?
Seconds.
Seconds. Good. Okay, next, here's the same problem. I just want you to look at what's wrong with it. So turn to your neighbor or someone next to you. Chat with the person next to you. What's wrong with this setup? Instead of the boxes, it's like X in a line. But it's the same idea. Okay, what's wrong with this problem? Okay.
Days are on top of the first.
All right. These two are just in the wrong order, right? Days has to be flipped so it can cancel. If you flip those two numbers, does everything else work out?
Yes.
Good. Okay, one last problem. I drive 5.80 miles to school each morning. How many inches is that? And then how many centimeters is that? Express your answers in scientific notation. Okay. What number is given to you in the word problem?
5.8 miles.
Okay. So we know we're starting at 5.8 miles. What's the first unit we're trying to convert to? Okay. So we're first going to convert that to inches.
Centimeters.
Okay. And then what's the second unit we're going to convert to? Okay. And then we'll eventually convert that to centimeters. Okay, so I'm first just going to start going from miles to inches. Do we know how many inches are in a mile? Okay. Do we know how many feet are in a mile?
5,280 or something.
That's exactly right. Okay, so we can go from miles to feet. Do we know how many inches are in a foot?
Yes.
Okay, so we can go from miles to feet to inches. And then for our second problem, are you given the conversion from inches to centimeters?
Yeah.
Okay, so then from inches, can we go from inches to centimeters?
Yeah.
Okay, so then that's how we'll do part 2. Okay, so now we'll do our dimensional analysis. What number goes in that first box?
5.8 miles.
Okay. 5.8 miles. When we say 5.8, we typically don't say the 80. However, should you make sure you write the 0?
Yes, because they made it important.
Okay,
They
yeah.
made it a sig-
You're going to need this for sig figs, so make sure you catch the 0. How many feet are in a mile?
5,280.
Okay, so we know there's 5280 feet in a mile. And then how many inches are in a foot? Okay, so go ahead and calculate how many inches are in 5.80 miles. This should be a big number. What do you have?
367,480.
88?
Yeah.
Okay. Do y'all agree with that number? Okay.
But it's over one, so it's just
Yeah, just over 1. Okay, how should we express that answer?
scientific notation.
Okay, scientific notation. So sig figs, how many sig figs are in 5.80? 3. 5280 feet is the measurement in a mile, so how many in 5280? 3. This one we're not going to count because it's a definition. So how many in your answer?
3.
Okay, so here's that third sig fig. Are you going to round that up or down?
Down.
Okay, so we're going to round it to 367,000. So what is that in scientific notation?
36.7. Oh, 3.67 times 10 to the third, fourth, fifth.
Degree? Count. So it starts here. So 1, 2, 3, 4, 5.
Oh yeah.
Okay, and what's our unit? I think that's inches. Okay, so that's part 1. Are we done?
No.
Okay, part 2 is just converting from inches to centimeters. Okay, are you ready for this step? Okay, we don't round until the very end of your problem. So when we're going to go from inches to centimeters, you've got to go back and start with your unrounded number. Okay, you round at the very end. Because did we round quite a bit?
Yeah.
Okay, so we don't want to round yet. So you're going to go back and use this old number. So I'm going to use 367,488 inches. And we'll use that number to convert to centimeters. How many centimeters are in an inch?
2.54.
Okay. Does the 2.54 have to go on top or bottom? Okay, so there's 2.54 centimeters in 1 inch. Okay. So now what do you get when you multiply those two?
933,419.52.
Okay. Do y'all agree with that number? Okay. We have to round. Now, even though we don't round to the end, how many sig figs was this number only good for?
3.
Okay, so 3 sig figs is still going to carry over here, even though we're just not rounding it. So 3. Also, how many sig figs are in 2.54? 3. So how many needs to be in your answer?
3.
Okay, so there's that third sig fig. And what's that 4 going to cause you to do?
Round down.
Okay, so we're going to round it down to 933,000. And what's that in scientific notation?
9.33 times 10 to the fifth.
Good. And what's the unit?
Centimeters.